This time we're supposed to convert the decimal number to the 8-bit number in 1's complement form. What we're supposed to do first? Look, we have negative sign. At this moment we are going to ignore this sign and simply convert 54 to binary. 54 you can build from 32 and 16. We have 32 plus 16 gives me 48, plus 4 gives me 52, plus 2 gives me 54. Okay, and I'm supposed to have 8 bits this time. So I have 1, 2, 3, 4, 5, 6. I need 2 more bits. I'm going to add 2 zeros. And this is my positive 54. So I have 0, 0, 1, 1, 0, 1, 1, 0. Next, you're supposed to find the 1's complement of it by simply finding the complement of every single bit. Means you have to write 1, 1, 0, 0, 1, 0, 0, 1. And this is negative 54 in 1's complement form. Let's take a look at the next example. This time we have positive 67. We're supposed to express this in 1's complement form. But remember, anytime we talk about the binary sign numbers and we talk about 1's complements represent negative numbers. The number which is given on the board is positive. So this is just positive number. So what you're supposed to do, you're supposed to just simply this 67 to binary. And this is going to be 64 plus 2 plus 1. 64 plus 2 is 66 plus 1 is 67. This is my 67 in binary, and I'm supposed to have 8 bits. I have 0, 1, 0, 0, 0, 0, 1, 1. I have 8 bits, and because the number which was given is positive, and no matter that we have to find 1's complement, the answer for this problem is this one, because this is positive number. 1's complements represent the negative numbers. This is the solution to my problem. And we have another example on the board. This time we have negative 103. This is the negative number. Remember, 1's complement represent the negative numbers. What I'm supposed to do first? At the moment, I have to forget about the sign for a moment and convert 103 into binary. 103 is going to be built from 64 and 32. 64 plus 32 gives me 96. Plus 4 is going to give me 100. Plus 2 is going to give me 102. Plus 1 gives me 103. I'm supposed to have 8 bits. That's why I'm going to fill up these spaces by zeros. And this is my positive 103. Okay, in binary. Next, because I have negative sign, I'm supposed to complement every single bit of my number. So I'm supposed to convert 0 to 1 and 1's to zeros. So this number is representing negative 103 in 1's complement form. So this is the solution to my problem. Let's take a look at this example. Please notice that this number is positive. We simply convert the positive numbers to decimal, and this is going to be our answer. If comes to the signed numbers and conversion to the 1's complement form. Again, because this is positive, we simply convert 111 to binary. 111 in binary is 1 1 1 1 1 1. Let's check. We have 64 plus 32 is 96, plus 8 is 104, plus 4 is 108, plus 2 is 110, plus 1 is 111. Okay, so I have 0 1 1 0 1 1 1 1. So this is the solution to my problem. Remember, this is positive number, that's why this is my answer.